In this video, I'm going to talk about this concept of resonance. So basically, we have to introduce this concept because sometimes it's possible to draw more than one valid Lewis structure for a molecule. Sometimes Lewis theory doesn't quite capture the reality of the molecule, so we need some framework within Lewis theory to take care of that. So to show you what I'm talking about, I'll start with an example. So for example, here I have the ozone molecule, O3, and beneath it I have drawn two Lewis structures. So this one on the left over here has the double bond between the middle and the right oxygen, and then this one on the left has a double bond between the central and the left oxygen. So the next logical question is which one of these structures is correct? And the truth is, within Lewis theory, they're both equally valid, but in reality, when you do an experiment and measure the bond strength between these oxygens, it kind of seems like the oxygens each have a bond with about 1.5 bonds between them. So what that really means is that the electrons are kind of spread out evenly over the oxygens. So, like I said, the electrons are spread out evenly. This is called delocalization. But this isn't something that we can capture in Lewis theory. In Lewis theory, the electrons belong to one atom and everything is, everything has like a little address, so that's called localization. When the electrons belong to one place, or one atom. So how do we represent this in Lewis theory? So our real structure, you can think about it as something like this. So as I've said, there's about 1.5 bonds between each of the oxygens. So the way this is represented in Lewis theory is by this concept of resonance. And people typically draw something like this between every valid structure within Lewis theory. So it's this double-headed arrow. And it's kind of like saying, hey, it's either this structure or that structure. But in reality, it's an average of these structures. So lucky us, we get to draw all of them. So for this example, there were these two valid structures and they're both equally likely. So the average for this case, both of the structures are equally likely. But that's not always the case. So sometimes the resonance structure is, so there's, more than two resonance structures and there are very different resonance structures and one is better than the other. So when that happens, the resonance structures can be unequally weighted. So let's just summarize that. So sometimes there's more than two. And also, one can be better than the other. And when that's the case, they're going to have unequal weights. And of course, we need to come up with a way to figure out what better means. So let's call it better. So we're going to do that in the next lecture. And this concept of figuring out which one is better, we assign something called formal charge. So that's going to help us and kind of come up with a quantitative way to figure out which resonance structure is the best.